In Part 3 of the Introduction to Smoke lectures, you will learn about the Smoke user interface. Smoke is a command line based program that is configured and run using scripts. In the following slides, you will be introduced to the Smoke assigns file, some of the most important Smoke environment variables and settings, and the Smoke run scripts. The Smoke assigns file is a large script that is used to assign all of the input-output directory and file names used by Smoke. It includes global run settings, such as the output grid name, the chemical mechanism name, and the modeling episode start date that you're using in your simulation. Assigns files are simulation specific. For each new Smoke simulation, you will create a new assigns file. In general, new assigns files are created when you change or update inventory sources or change modeling domains. The assigns file is used by all of the Smoke run scripts for setting up the Smoke operating environment. The assigns file is also handy for setting environment variables to use when navigating the Smoke directories and files. You will practice using the Smoke assigns file during the hands-on exercises of this training. The settings in the Smoke assigns file are invoked using the Unix source command. By sourcing the assigns file, using a similar command line argument as seen in this slide, you configure your operating environment for running Smoke. The next few slides show some of the hundreds of environment variables set in the Smoke assigns file. The ones we show here are key variables that are commonly used to navigate the Smoke installation. The Smoke environment variables that get set when you source the assigns file are shown in bold on this slide. The logical name or environment variable SMKROOT sets the main Smoke installation directory on your system. Within the SMKROOT directory, you will find the assigns files, which can be quickly accessed using the assigns environment variable, the run scripts, accessed with the scripts/run path, and Smoke source code and Smoke executables. SMKDAT is the Smoke data directory. Within SMKDAT are all of the input and output directories used by Smoke. The variable INVDIR aliases the Smoke inventories directory. GEDAT aliases the general data directory with all of the ancillary data, and INVOPD aliases the intermediate and output data files. Within the INVDIR directory are subdirectories for the area, biogenic, mobile, and point inventories. For example, to list the area source inventories for your Smoke project, you could change directories or list the contents of the ARDAT directory, using the variable ARDAT as the alias to the actual directory path. The GEDAT, or General Data Directory, houses all of the Smoke ancillary data, including the spatial, chemical, and temporal profiles and cross-reference data. METDAT is the environment variable that aliases the meteorology data directory in Smoke. The directory INVOPD is the location where the outputs from Smkinven and Grwinven are written. Scenario is the directory location of the time-dependent intermediate output files, including the outputs from the Temporal and Laypoint programs. Static is the location of the time-independent intermediate output files, including the outputs from SpecMat, GridMat, ControlMat, and ELEVPoint. The outputs from Smoke merge are written to the AOUT, BOUT, MOUT, and POUT directories, where A equals area, B equals biogenic, M equals mobile, and P equals point. The output from the merge grid program is written to the directory aliased by the environment variable output. The Smoke QA program Smoke report outputs time-dependent or scenario reports to the rep_sen directory, and time-independent or static reports to the rep_stat directory. Where the previous environment variables set aliases to directory paths, the environment variables shown on this slide set parameters for the configuration of a smoke simulation. The environment variable grid sets the grid name to be used in the output file names from smoke. The environment variable IOAPI grid name 1 sets the name of the modeling domain, which is defined in the IOAPI grid description file. And SPC is the environment variable that sets the chemical speciation name to be used in file naming. The environment variables in this slide are set in the assigns file and configure the episode and simulation time periods for the smoke run. The EPI or EPI variables are used to configure the smoke episode period. If you want to set smoke up to run for several days, you would set the EPI variables accordingly. The G underscore variables configure the timings of the individual days processed by smoke, including how many hours of data to write to each smoke output file. The smoke run scripts are distinct from the assigns file in that there is a separate run script for each inventory source category that is being processed, where you have a single assigns file, a central assigns file, that's used by each of the source categories' specific run scripts. The assigns file is specific to the smoke simulation, where the run scripts are specific to the inventory source categories being processed for that simulation. In general, the smoke run scripts all follow the same basic structure. They all begin by setting the assigns file that contains the configuration settings of the smoke simulation that you're going to run. The scripts then set the source category that you're processing using an environment variable. The source category is set to either area, mobile, point, or biogenic. The scripts then set which smoke programs to run, such as Smkinven, GridMat, SpecMat, smoke merge, etc., along with the configuration settings and options for each program. After listing a few variables that allow users to override some of the settings in the assigns file, the run scripts source the assigns file to invoke the settings for the simulation, and then the smoke programs are all run. The smoke run scripts are configured to handle the looping across multiple days if a multi-day simulation is being simulated with smoke. This concludes part 3 of the Introduction to Smoke lectures. In the next set of slides, you will learn about processing moves data using the Smoke Moves tool.